This is OwlUp, where learning happens in minutes, not hours. For a deeper journey, explore all our courses at owlup.co. Now, let's dive in. Welcome to Chapter 1 of our series, From Pixels to Predictions. In this episode titled Understanding Computer Vision and Its Applications, we're going to explore the fascinating world of computer vision and uncover how it's transforming industries all around us. So, whether you're curious about how your favorite apps work or the future of technology, let's dive in. A camera in a hospital spots disease more accurately than most doctors. A camera in a car makes split-second decisions at highway speeds. A ceiling full of cameras at an Amazon Go store watches you grab snacks, then quietly checks you out as you walk away. No cashier in sight. Most of the time, you don't even notice it working. Unlocking your phone with your face, autofocusing on a friend in a crowded photo, blurring the messy background on a video call. These everyday tricks are all quiet victories of computer vision. Behind the scenes, billions of images and videos are flowing through algorithms that have learned, from massive labeled datasets, to spot patterns far too subtle or too fast for humans to track. Deep learning models sift through medical scans, factory assembly lines, traffic intersections, and social media feeds, turning raw pixels into predictions and decisions. Think of it less as cameras getting smarter, and more as software learning to see well enough to safely drive, diagnose, inspect, and personalize at global scale. Yet, teaching machines to see isn't one thing. It's a stack of specialized skills. One system reads road signs at 120 kilometers per hour. Another spots microscopic anomalies in a retinal scan. Another tracks defects on a conveyor belt thousands of times per minute. Each is trained for a narrow job, tuned to conditions, and evaluated with ruthless statistics. Like AlexNet's breakthrough on ImageNet, or face recognition surpassing humans on LFW. That's why vision is creeping into everything, from crop monitoring drones to stadium analytics, wherever cameras already exist and decisions hinge on what they capture. Walk through a modern city and you're moving through one enormous vision system. Traffic cameras track congestion, warehouse robots follow floor markings, drones survey construction sites, and your doorbell watches the front porch. The common thread isn't just seeing, it's extracting the right signal from endless, messy visuals and plugging it into a workflow that matters. Under the hood, most systems tackle three broad jobs. First, what's in this frame? That's classification, labeling an X-ray as healthy or suspicious, or a satellite tile as forest versus urban. Second, where is it exactly? That's detection and segmentation, putting boxes or outlines around pedestrians, forklifts, tumors, hail-damaged crops. Third, what's changing over time? That's tracking and action recognition, following a specific vehicle across cameras, or recognizing when a factory worker steps into a restricted zone. The magic isn't only in accuracy, it's in context. A model that spots a tiny crack on an airplane wing is useless unless it ties into maintenance schedules, risk thresholds, and regulatory logs. That's why some of the most interesting work now happens at the edges of vision, combining visual cues with sensor data, business rules, and domain knowledge. We're also seeing a quiet architectural shift. Instead of streaming video to distant servers, more analysis runs where the pixels are captured. On phones, cameras, AR headsets, even smart traffic lights. This edge processing cuts delay, preserves privacy, and lets vision power use cases like on-device fitness coaching or real-time quality checks on a factory line with no stable internet. A helpful way to think about this layering is like a financial analyst's workflow. Raw price ticks, pixels, get cleaned and aggregated, basic image processing. Patterns are modeled, vision networks, and then those outputs feed portfolio decisions, applications. Each step adds structure, value, and constraints. Despite headline-grabbing milestones, open-ended understanding remains brittle. Unusual weather, new camera angles, rare medical conditions, or simply a dirty lens can break assumptions. That's why leading teams obsess over diverse data, careful evaluation, and human oversight, not just bigger models. Think of how a good chef uses sight in different ways, checking if a steak is browned enough, spotting a shell fragment in egg whites, or judging whether a sauce has split. Computer vision is playing those same kinds of roles across industries, highly specific, context-aware, quietly critical. In retail, it tracks how shelves empty out so staff restock the right products, not just the nearest ones. In sports, it follows every player to compute sprint speeds, fatigue patterns, and optimal passing lanes, feeding coaches insights mid-game. In agriculture, drones scan fields to flag dry patches or early disease before the human eye would notice, letting farmers irrigate or treat only where needed. In cities, vision-equipped traffic lights adapt timing based on actual congestion instead of fixed schedules, shaving minutes off commutes. Even in creative work, tools rearrange furniture in AR, clean up reflections in product photos, or generate depth maps from a single shot so filmmakers can relight a scene long after it was filmed. By the time cameras understand most public and private spaces, the big question won't be, can we see, but who controls what's seen and remembered? Expect vision to shift from single gadgets to shared visual infrastructure, like plumbing for perception, apartments that log leaks, gyms that score your form, streets that reroute traffic as conditions change. The more fluent systems become at reading the world, the more pressure we'll feel to negotiate where they must stay blind. As more lenses join homes, streets, and workplaces, seeing systems start to feel less like tools and more like collaborators, spotting hazards like a cautious coworker or surfacing trends like a sharp analyst. The real frontier isn't sharper vision, but aligning what's watched, stored, and shared with the futures we actually want to build. Try this experiment. Grab 20 to 30 photos from your phone, people, pets, streets, food, and run them through a free online computer vision demo like Google Cloud Vision or Microsoft Azure's Vision Playground. Look at the labels, objects, and text it detects, then deliberately break it by using weird angles, low light, or partial occlusions. For example, half your face covered, a dog behind a chair, and run those photos again. Compare what it gets right versus wrong, and jot a quick note on which conditions, lighting, distance, clutter, most affect its accuracy. This will give you a hands-on feel for how robust and fragile real-world computer vision really is. This was OwlUp, your daily step forward. To keep learning with structured courses and more insights, go to owlup.co. Until tomorrow!